do that one day, but not today. Actually, no, I can't even guarantee that. Anyway, so we're back live. For those of you in the live stream, I'm going to remind you a couple times to make sure you leave that comment. That would be fantastic. Here is the rundown of today. Number one, on the Chromebooks, I have an activity that I would like you guys to get partially done using something on Desmos. I am going to have a link available to you in a little bit. I have not made that link live yet, but I'm going to make that link live to you, and then I'm going to walk you through the first couple of examples, and then I'm going to give you an opportunity to try some of these on your own. You'll see that, and for those of you in the live stream, of course, you'll have the exact same opportunity. Yes? Is he okay? No. He's not? Cool. So, after said Desmos activity, I do have a short bit of notes that I would like to take with you, continuing what we were doing with graphing these types of problems. Obviously, I was out on Wednesday, and I gave you some practice on identifying certain types of asymptotes and x-intercepts, especially using any type of graphing capability, whether it be Desmos or the calculator on your Chromebook and whatnot. But I want to take some notes, kind of expanding our knowledge on graphing these things one more time. And then, well, remember what we did on Monday for the last 23 minutes? We had that, the what? Yeah, we had that pre-assessment, right? Yeah. Well, based on that pre-assessment, you were either placed into mastery or non-mastery, enrichment or remediation. And again, these procedures that we're going through are not my ideal way of handling an extra 23 minutes at the end of class, but lo and behold, this is what we have in store. If you did not take the pre-assessment, unfortunately, I had to put you into the non-mastery group. But keep in mind, obviously, there will eventually be another pre-assessment with a different standard that you would be able to prove yourself on. So for the last 23 minutes of class, when we get to noon, I am going to be sending out 2 emails. You will receive one of these emails. And that email will indicate to you whether you hit mastery or non-mastery, enrichment or remediation. Inside that email is a link to a Google Slides assignment in which you will complete said Google Slides assignment. If you are remediation, then there is a short video in there for you to watch to help with some of the problems that are on that particular Google slide. You can watch said video with earbuds, headphones, whatever, what have you, and then obviously complete said assignment. Then there is, for the enrichment kids, a different Google Slides, which has a different assignment. Again, not my ideal way of handling an extra 23 minutes, but this is what we're faced with this cookie cutter kind of assignments for enrichment and remediation. So probably around 11:55, I'm going to send out those 2 emails. They're already ready to go. And then you will know what your assignment will be for the last 23 minutes. Now, being that this is our first quote-unquote intervention period, I'm not going to have the assignment due at the very end of class. I'm going to give you a little bit more time to do it. Now, yes, I know it's Friday, but I'm going to extend the due date time for this to tomorrow morning. So that, for example, oh, I didn't finish it in class. Okay, well, I mean, yes, I could leave it for 2 o'clock, but you do have a 4th period class. Oh, I didn't get it done in the afternoon. Well, you might have a job, sports, what have you. So I'm giving you that extra time to get it done and into me. Bless you. The pre-assessment doesn't count against you, but these other assignments, they will need to get done. So first things first. On Google Classroom, I want to do this Desmos activity with you. So let me load this thing up right here. And let me make this thing live. Assign, blah, blah, blah. Yes, see it immediately. Boom. Go to your Google Classroom streams on your Chromebook. That would be absolutely wonderful. And there should be an assignment called Marble Slides Rationals. If you click that, it'll take you to this where you can type in your name and get that thing done. I'm going to do something similar here. Click go. Boom. And it will initialize the activity. Some of you probably already have an understanding of what marble slides actually are from some previous year of mathematics. That's fine. That's perfectly fine. I don't believe that you have done this particular marble slides. So let's see what we got here. Marble slides. This thing right there. Boom. There we go. Now, don't go past the first slide just yet. For those of you who don't know what this is, I don't want you to go past the first slide just yet. But as you click on that link and as you enter the name to get into the marble slides, it has your name already there. You can see that up here on this grid, it'll show that you have joined the activity. And I can see that Paul has moved on to the second slide. Well, like I said, I want to kind of walk. I know that some of you probably already have an understanding as to how this works, but I want to walk you through the first little bit. So I'm going to tell you, go to your Google Classroom, open up the assignment, click the link, click to join with your name, obviously, and then I can see you pop up right there, and it'd be fantastic to see you all right there. Now you can see, Paul, you have a check in your first box. You know why? No guesses? Why you have a check in your first box? Check this out. No, because the thing allowed you to because you followed the directions. It says, here's the goal. Get all the stars. Get to know rationals. Click launch to see what we mean. So yeah, go ahead and click launch. Boop. And then once it hits all the stars, you see a giant success. And then when I go back to here, oh, it doesn't load. It doesn't give me the check mark just yet. I think if I click next, it'll give me the check mark. Oh, Paul, how did you get the check mark? I didn't. But I did it. Look, launch. Whee. Click next. I don't know. Well, it updates it in real time. Why are you the only one with a check mark? I don't know. Now, I know that there are names online. I saw the names online right here, and I can see all these names of people right here. And I know some of the names in the chat that haven't joined yet. Make sure you are joining this thing. I can see exactly who's on here and who's not. Yeah. Now, what I want to do, yes, obviously, you can pass these levels at your own pace. But for those of you that might be a little bit like, what the heck is going on with this thing? Let me walk you through it. What's going to happen on each of these slides? And we're only going to go really through the fix it ones. They want you to fix the equation to the left by changing one number. Just changing one number. And if you change that one number, then when you launch that purple ball, it will hit all of the stars. So if I click launch right now, clearly it's not doing that. It'll go back up there. But some of you, I believe, let me double check this. I believe, based on what you said, some people, oh, look, she got a check mark next to her name. Now you got the check mark. Jessica, you do. Yeah. How'd you get the check mark? Well, how'd you do it? Sure, let's give it a shot. Change the -2 to a +3. Let's launch it. Success. Was +3 the only number you could have used? 4 doesn't work. 2 doesn't work. What about 2.5? 2.5 might work. Hold on. 2.5 works. There is more than one way to do these problems. Oh, look, a bunch of you got check marks. Huzzah! I'm sorry. Did you do it? I don't know. Maybe it's got to update. Now, if I go next, it'll bring you to the screen where it says reset. Basically, if you mess up the equation beyond repair and you're like, holy crap, let me just start this slide over, you can click the little settings wheel and it'll give you the option to reset right here. If you click that little wheel, it'll give you the option to reset and you'll be able to go back to normal and try it again. So let's try one more together, and then I'm going to give you an opportunity to try a few of these on your own. If you go to fix it number 2, clearly this is not working. But they say, according to the directions, change the sign. The sign now, they're giving you a huge hint. Change the sign on one of these numbers in the row below to fix the marble slide. Anybody know what sign I got to change? Because you can mess around with it. You could literally experiment by changing a few different, one different thing, really. They want you to change one number. But by changing it and trying a few different ways, and then if you really get messed up, you can always reset it back to normal. I could go -5, and then let's see how many I can get. Just clearly, I can't even get 1 there, so that -5 didn't work. Let me reset that sucker. Let me change that 4 to a -4. Oh, holy crap! Did it work? Sweet. There it goes. I actually had some tweets back and forth with the guy who designed the code on this website because I was asking him about the purple balls, because the purple balls drop in marble slides, but they actually fall according to a probability distribution function, because they look like they fall the same way every single time, but they actually don't. There's slight differences in the way that they fall according to some probability distribution function that he does. Let me go check back. Look at the chart right here. Boom, bunch of you got check. Look at that. Look at all those checks right there. Look at all those checks. So here's what I want you to do. Here's what I want you to do. I want you to take the next few minutes to mess around with fix it number 3, fix it number 4, and fix it number 5. Now, you don't understand everything that there is to know about rational functions. I know that you don't, because I haven't taught it all to you yet. But I want to see what you can do. And I'll explain why we kind of did this after the fact. So take some time. Get those check marks for fix it 3, fix it 4, and fix it 5. Go! And just for the sake of argument, if you on number 2, if you just change that 4 to a -4, it works. And of course, reminder to those of you in the live chat, please make sure that you're leaving that comment.
Which ones are we going up to?
Up to number 5, because after number 5, it gives you a prediction, and then it asks you to verify it. So the website won't automatically tell you that you're right or not. A bunch of you, I can see at least 3 so far. I've gotten check marks on fix it 5. Because then, yeah, after that, it's like verify a bunch of stuff. If you're interested, I'm not going to ask you to do it, but there is a challenge slide down the line in which you actually have to create your own equation from scratch. I'm not asking you guys to do that today, at least. I'd rather just focus on the what you guys got here for fix-it 1. I'm sorry, 3, 4, and 5. On fix-it 3, I didn't really explain this, but what does that x less than 9 do to the equation? What the heck does that less than 9 do to the equation? Or better,
It makes the line move over the
what do you mean? What did you change it to? 10.
10.
And it moved over, right?
Yes.
Technically, what this x less than 9 does in brackets is it graphs the equation like normal, but then it just comes to a stop. So it's not that it actually moves the equation, but it allows the equation to keep extending. Yeah. So changing that 9 to, let's say, like a 10 or an 11 would definitely force that thing to be correct. Let me do that real quick. 10. Launch. Oh, look at that. You got some that fell off too, right? Did some fall off for you?
Yeah, but it's still.
Oh, of course it does. Yeah, because you only need one of them to go through it. But if you did like 11, let's say, I believe they should all work.
One of them, like, oh, I put 11 and like one of them stayed at the top.
Yeah, like I said, like, you know, one of yours stayed at the top, all of mine fell down. That's the randomness in the balls, in the way that they're falling. They're trying to replicate like real life, I guess. Because if you spin like a, like a coin, it's not going to land on the same side every time, unless it's a fixed coin. Fix-it 4, clearly nothing's going to work right here. They say to change one number, but there's only one number there. So if I change the number at the top, make it a 3? No. 5, 6, 7, 8. What'd you guys make it? Will 12 work?
I made mine 17.
Ooh, let's try
I
17.
had to keep like inching up because like one of them wouldn't.
There we go. Yeah, that's what the number on the top does. It actually just kind of forces that thing out a little bit. It's really weird. And then fix-it 5. Ooh, change one number to fix the marble slide. What number do y'all change?
I think it's negative 5. Or the plus one, I think it's negative 5.
-5?
Yeah.
Oh, nice. You know what it did? It moved it in what direction? Yeah, it shifted it horizontally. It shifted it horizontally if you change that +1 to a -5. Yeah, that's what these things do. You change one little number, and you can get that thing to shift over in whatever direction you want it to do. You can get it to shift in the horizontal direction. You can get it to shift in the vertical direction. You can get this thing to change its not its amplitude or what it's called, but how steep it is. Like, this thing is insane. A few years ago, I was in a professional development with a professor who created and taught lessons exclusively on Desmos. And I thought it was the coolest thing, because basically all the teachers that were in this professional development, all these teachers were working through different lessons on Desmos, and we were being challenged to like some more extreme things, like way more extreme than what you guys see here. And we were told to create equations in such a way that will hit all the stars, just random challenges. And I remember it getting very competitive amongst the teachers. A lot of fun. But of course, we were using a bit more advanced calculations. We weren't just using straight lines. We were trying to create like curves, a single curve that would actually hit everything that we needed it to hit. It was insane. I loved it. But yeah, Desmos. And I can see a bunch of you already got that check mark down there. Like I said, later on, they say to make a prediction and verify and stuff like that. That's stuff that would have to be like graded by hand by the teacher. But then eventually when you get down to 17, they have something that's like a challenge slide almost, where where you're like, okay, well, maybe I can figure out something. Maybe I'll start with a 1 minus x. Clearly that doesn't work. What if I try that 17 thing again? Maybe not. 11? 19? No, maybe I have to go a bit more advanced than this. Oh, there we go. That's something that could work. Let me shift that thing up. 5. Nope. Move it down. 4. Nope. Move it down. Could that work?
It's not going to be
That's part of the challenge, like messing around with it and just seeing what can I add to the equation that could get it. Heck yeah. Just like random stuff like that. And then you see the success, and then I go back over here, and then when you go over to number 17 for me, there's a check mark. And it's like, yeah, I got that check mark. No. But again, I'm not expecting you guys to do this challenge. Oh, I can do that one. Check this out. Ready? You see the challenge number 3, challenge slide number 3. It's like you got them to the left and to the right. I know which one to do for this only because of the experience. There it is. Boom. Oh, no, it didn't work. How come it didn't work? That's true. Oh, snap. So how do I get them to be not connected in the middle, but how do I get them to split to the left and the right? But that's the thing, though. It's like if I do like another equation like this, like that.
Well, is there any way that you can cut?
Yeah, you can cut the line.
Yeah, do like
Whew.
the brackets and make it stop at
You have
like,
to put the brackets for that one, and you can cut off the very top.
All right, hold on. I got this. X is greater than 2, 1, 0.5 bracket. Check this out. I'm going to create a second equation. Oh, no. Okay. That's okay. I copied it. There we go. I'm going to create a second equation, but I'm going to make it x is less than negative 0.5. There we go.
And then
And they need to move the up a little bit. I don't think that they're going to, I think they're going to go straight down.
I got this. Check this out.
equals 5.
but then make it stop. Like, yeah.
And,
X equals 4.
hold on. X is less than 0.5.
And then negative.
Negative 0.5. If this works, I swear. Come on.
No.
They just stuck at the top, you know.
That's why I was saying
Well,
make
then
them
maybe-
longer because then they'll be on the side.
Maybe if you do 2 lines and you make them kind of equal.
Maybe. That's for another day, though. But this is what I'm saying, though. It's like just the experimentation of just trying to figure out, like, what type of equations can I get in there where if I just launched it once, it would actually hit both to the left and to the right. It's an amazing system. I love it so much. Okay. That was just to kind of get your minds wrapped around the idea of rational functions. Now, rational functions, we've been dealing with graphing them. I've been giving you strategies for graphing them. I've been giving you strategies for identifying certain asymptotes and x-intercepts and getting the table of values. This was just trying to show you, again, just to get a little bit more familiar with their structure, with changing certain numbers here and there, changing the way that they look on the screen. It's an amazing system of equations. Here's what I need you to do. We're going to put the Chromebooks on hold temporarily. We don't need the Chromebooks for the next part, but we will need the Chromebooks from noon to the end of class. But what I need from you right now, if you do not already have them out, I'm going to need those notebooks out and open. Yeah. I got you. You put the magnet in the door. There's a magnet. No, instead of that, you put the magnet in the door. It's just a little bit easier. There we go. Okay. So this is April 30th, last day in April. Huzzah, huzzah, huzzah.
Wait, April doesn't have 31.
No, 30 days past September, April, June, and November. Okay.
Is Sharon back saying that same thing, except she included April and 31?
Oh, no. All the rest have 31, except for February, which is terrible. Zooming in. Graphing, rationals, continued. Graphing, rationals, continued. Last class, or not actually last class, probably on Monday. On Monday, I gave you a set of cases that could potentially happen when you are graphing rational functions. And the cases, well, the paper on the notes looked something like this. Now, I'm not going to keep this paper up here because we copied it down on Monday, but this is what we copied down on Monday. I said there were 3 cases for the degrees of these rational functions. If the top and bottom are equal in terms of degrees, well, that's the case that we dealt exclusively with on Monday. If the degrees are equal, then you can get your horizontal asymptote by dividing the leading coefficients. And if you were able to get that done, then we can go through the rest of the steps to get the vertical asymptotes, the x-intercepts, and eventually the table of values. But today, I just want to focus on an example that deals with the denominator having the larger degree. If the denominator has the larger degree, then your horizontal asymptote is automatically y equals 0. There's no getting around it. If the denominator has a larger degree, then the horizontal asymptote will automatically be y equals 0. Then we can proceed with everything else. So here's the example that I have for today. Well, actually, let me write down case 2 first. This is case 2. Just want to write it down again. The degree of denominator is larger. Remember, the degree is the largest exponent in that particular equation. The largest exponent in that equation. The example that I would like to write down is y equals 5x plus 1, the whole thing over x squared minus 1. That is the example I want to focus on for today. Because of case 2, your horizontal asymptote is y equals 0. This is an absolute given. The degree of the top of the equation is 1. It has a largest exponent of 1 right there. The largest exponent on the bottom is 2. Well, because the degree of the denominator is larger, automatically your horizontal asymptote is y equals 0. And we're going to have the opportunity to graph that. We will have the opportunity to graph that in a few moments. First, we have to identify all the other stuff. Here's going to be your procedures. We need to identify your asymptotes, both horizontal and vertical. It'd be a great idea to identify your x-intercepts. You need to get a table of values from a calculator of some sort, and I'll use the one on my computer in a moment. And then we're going to graph this thing out. So we already found our horizontal asymptote because of case 2. Now I want to find my vertical asymptote. If you recall back to Monday, and this is where you really got to look back in your notes. You look back in your notes and you see, well, if you set the denominator equal to 0 and solve, then that will get you your vertical asymptote. That will get you your vertical asymptote. Now, if I take this denominator, which is x squared minus 1, I have to solve that. I have to get that equal to 0. Well, it already is equal to 0, but now I have to actually solve for x. The key is factoring, factoring, factoring. We've been factoring since September. We factored in chapter 5, factored in chapter 6, factored in chapter 8. I reintroduced factoring to you right after spring break, or even right before spring break. I can't recall, but still. Factoring is the name of the game. If you were to factor this correctly, you would get x minus 1, x plus 1, which would allow you to solve for your 2 vertical asymptotes. You have 2 vertical asymptotes here. X equals positive 1 and x equals negative 1. Again, notice how I labeled that little section of my notes as VA, vertical asymptotes. Very important for you to keep your work organized. Your horizontal asymptote is determined by case 2. Your vertical asymptote, well, so far we determined that by setting the denominator equal to 0. Now I want to find my x-intercept by setting the numerator equal to 0. If I set that numerator equal to 0 and solve that, that will get me my x-intercept. Now, I don't have a quadratic this time around, but it should only take a few moments to figure out that it should be negative 1/5. Should be negative 1/5. Again, notice how I am labeling each of the sections where I'm getting my work from. Horizontal asymptote usually determined by one of those cases. The vertical asymptote, you set the denominator equal to 0 and solve. The x-intercept, you set the numerator equal to 0 and solve. The only thing left for me to do is a table of values. I'm going to go to my calculator for that. I'm going to leave this up for a moment, but I got to go to my calculator to get this thing done. So I'm going to bring up the calculator that is on my computer. Let's see what we got here. There it is. Clear that. Y equals parentheses 5x plus 1, close parentheses, divided by parentheses x squared minus 1, close parentheses. Make sure you know how to type these things in correctly, whether it be on the computer or a handheld graphing calculator. If I hit second graph, that will bring me to my table of values. Look what we got here. Look at these numbers. Some of these numbers are terrible. If you look at some of these numbers, like right here, look at this. There's no stinking way I would have you even write any of these numbers down. These numbers are too small. I mean, they're not too small, but they're all like very close together. The numbers that I am interested in, the numbers that you are going to write down as a result of putting this into your graphing calculator, should be the numbers that are surrounding your vertical asymptotes. This is what we wrote down so far. Yep. You should be writing down the numbers that are surrounding your vertical asymptote. Your vertical asymptotes are typically the ones, well, they have the word error associated with them. And you can see that right there. There are my errors. I'm going to write down some numbers from a table of values from this screen. I'm going to show you what I wrote down right here. My XY table of values, I would write down -3 and -1.75. I would write down -2, -3. I would write down 0, -1. I would write down 2 and 3.67. And I would write down 3, 2. Oh, sorry, Jessica, you asked if you could sign out of marble slides like 10 minutes ago. Did you? Oh, I thought you did. Oh, sorry. I didn't say the last name. I thought you asked it in the chat. That's my bad. It was a different Jessica. Yeah. Long story short, you can sign out of marble slides. That's all I really wanted you guys to do with it. Okay. We have several pieces of information from this previous page. She has my previous page, but that's okay. First of all, horizontal asymptote. The horizontal asymptote, here's what I need you to do. The horizontal asymptote is y equals 0. There is an axis that exists right on top of it. It's a solid line. Here's what I need you to do. I need you to embellish a horizontal line directly on top of that. I need you to embellish a dashed line right on top of it, just like I did right there. That is my horizontal asymptote. I would strongly suggest that you do it that way. You need to identify where that asymptote actually is, but at the same time, it's like, well, if you're drawing, pencil on pencil or pen on pen, it's a little bit difficult to see, so you need to embellish it just a little bit. That was my horizontal. There were 2 vertical asymptotes. One of them at +1, and one of them at -1. And you can see I put them right there. +1 and -1, there they are. I found an x-intercept at -1/5. There it is right there. There's my x-intercept at -1/5. Now it's time to just plot these points. You get them directly from the calculator, plot them out. I'm going to plot -3 and -1.75. I'm going to plot -2, -3, 0, -1, 2, and 3.67, about right there. And 3, 2. This should be, and it will be, sufficient information to be able to graph what the heck this thing looks like. Let me recap what just happened. Number one, if you're given this equation, you can determine the horizontal asymptote because of case 2, something we wrote down last time. If you have case 2, if the denominator has a larger degree, then your horizontal asymptote is y equals 0 no matter what. Oh, you got it? If you set your denominator equal to 0 and solve, you can get those vertical asymptotes. If you set your numerator equal to 0 and solve, you can get your x-intercept. And if you type this correctly into a calculator, you can get a table of values. Now it's time to draw this thing. Let me draw it in red. I want to draw it in red for some reason. Don't know why. This thing is going to flatline with the vertical. And it is going to flatline with the horizontal. On the far right side, it's going to flatline with the horizontal. And it is going to flatline with the vertical, trying to make that as smooth a curve as possible. The only issue that we are going to run into, hold on.
Miss Gidley, please call the main office. Miss Gidley, please call the main office.
The only real big issue that we're going to run into is the middle portion. What in the heck do I do for the middle portion? This is where your graphing calculator is going to come in handy. Let me go back. Hold on.
Mr. Claslow, please call the main office. Mr. Claslow.
This is where I go back to my graphing calculator and I actually take a look at this graph. Look what we got up here. Look at what we have up here. We have the far left. We have the far right. That portion in the middle is a little strange, but that portion in the middle is what we need to draw. And I would draw it like this. Still has the flat line with the vertical. It's going to do a little squiggle in the middle, and then it's going to flat line with the other vertical. That's what you have to draw. That's what this graph is going to look like. On the assignment that I gave you guys on Wednesday, you didn't have to go as far as graphing all of these, but you did have to go as far as identifying the horizontal, the vertical asymptotes, and the x-intercept with the help of graphing capabilities, whether it be Desmos or your calculator. I have one more thing to show you before we move to the intervention part of this class. I have one more thing to show you. I want you to write down one more equation for me. And I want to show you what the heck this thing looks like. Write down this. It's the last example we'll do today together before we set off on this intervention class period. You'll see. X squared plus x minus 6 divided by x plus 3. This example is exactly like, again, announcement.
Miss Gidley, please call the main office. Mr. Claslow, please call the main office.
You know, wouldn't it be simpler just to send someone down to where their office is to see if they're there? Oh, they're not there. Maybe ask the secretary that's in guidance or the main. Never mind. Anyway, back to this. This is everything that we've been doing, but I need you to see something. I need you to see something absolutely ridiculous. I need you to see something that is absolutely messed up with this equation. You have seen all sorts of crazy curves. You have seen problems that have curved with 2 different curves, 3 different curves, multiple vertical asymptotes. Watch what the heck happens here. Watch what the heck happens here. X squared, get back for that x squared. X squared plus x minus 6 divided by x plus 3. I need you to see this. Look what the heck happens when I graph this thing. What the heck is that? What is that? Yeah. Looking at the original equation, did it seem like it was going to be a straight line? No, it didn't. You thought it was going to be something really messed up, right? There's something hidden. There's something hidden that you don't know about just yet. Check this out. Check this out. This is really, really messed up. Look at this. -5. Oh, I got to put in the actual negative sign. My bad. -5. Look at this. Look at -5. You see it blinking right there? That's an ordered pair on this graph. That is an ordered pair blinking on this graph. -5, comma, -7. Watch this. -4. I put in that -4. Boom. Blinking on the graph. Nothing out of the ordinary. It's an ordered pair on this straight line. Yes, absolutely. Nothing wrong with that. Nothing out of the ordinary. Watch this. -2. Same thing. Same exact thing. Every number that I type in creates a blinking dot on that line showing me an ordered pair. Watch this. What happened? Say again? What's gone?
Well, it would assume if all the other ordered pairs that you put in created a blinking light, that -3 is for some reason not an ordered pair.
Say again? Oh, yeah. But it seems like it should be there, though, shouldn't it? Hold on, let me zoom in. Hold on, check this out. Zoom in right here. That should work. Okay, let me zoom in again. Oh, let me go back here. Zoom in again right there. And right there. Right there. I keep zooming in on this. Watch, this is like negative. Trace negative 3.000001. There's a blinking dot, right? But I go -3. I get nothing. Believe it or not, doesn't matter to me whether you believe it or not because I know it to be true. There is a hole in this graph. I need you to write down these statements. This graph contains a hole. There is a literal hole in this graph. The reason will be explained next time. On Tuesday, I am going to explain to you what the heck is going on with this hole, why it is there, and how you can tell that there's going to be a hole before you even begin trying to graph this thing. But that's what we're going to be doing. It's going to be insane, but we'll get there. Okay. Here is what I would like to do. I need everyone to go to your emails. Go to your school emails. And I am going to send out, let me freeze the screen real quick. There we go. I'm going to send out 2 emails. These 2 emails should determine to you, based on your, what's the word I'm looking for? Based on the pre-assessment that you guys did the other day. Send and send. Boom. They should determine whether or not your score indicated that you were in the mastery group or the non-mastery group. If you were in the mastery group, then you should be getting an email that contains this PowerPoint. This PowerPoint is the enrichment slide for this particular standard. There are questions on the first and second page that you will have to answer. I would suggest that you answer them on a separate sheet of paper, and that when the assignment is to be turned in, or before the assignment is to be turned in, well, you need to attach it. If you were in the other group, if you were in the remediation group, then you should have received this email, which contains a short video clip that you are going to review in order to answer this other set of questions. This is an elaborate thing that they have set up thinking that it will do great work. But as I said, the pre-assessment doesn't count, but this will. I need this to get done. Now, for those of you online, for those of you here in class, here's what we're going to do with the remaining time that we have. If you got the PowerPoint with the video clip, your job is to watch said video clip. I would use earbuds, headphones, whatever you got. as to not disturb other people. Watch said video clip, and then begin answering the questions that are attached to it. If you received the other email, you are to read the directions and to begin answering said questions that are on this PowerPoint slide. Now, I am going to be creating a Google Classroom assignment. I'm actually going to do that now while I'm talking about it. But I'm going to create a Google Classroom assignment that you will then have to submit the work that you do for this problem. Let me do that now. Let's see. Boom, boom. And like I said, I'm going to make it the due date and due time for tomorrow, simply because I'm giving you a little bit more time to get it done, but I am going to have it done for tomorrow morning. So, oh no, Mr. Markey, I wasn't able to get this done in class. That's okay, it's due tomorrow morning. Oh no, Mr. Markey, I wasn't able to get it done before the school day was over. It's okay, it's tomorrow morning. Oh no, I wasn't able to get it done in the afternoon. I had work or I had sports or whatever. Shut up, it's due tomorrow morning. That's what this thing is going to do. Paul, I just sent out an email to everyone. I sent out 2 emails, but you should have received one of them, indicating which group you were in. And then it has directions in that email to follow, of course, but then it has the PowerPoint slide that you were then going to do. Yes. Okay. I thought I had. Are you sure? Okay. But like I said, keep in mind, this is not due by the end of class. So, for example, if you watch the video with the captions on, that's fine for now. But then it's like, maybe I'll do this later this afternoon, or maybe so it's like later this afternoon, you rewatch the video and you can hear what they're saying.
What time are you making it due?
I made it due by 8 a.m. Yeah. I was just saying, because the idea was when they set up this remediation thing, they wanted everything turned in like by the end of the class period. I'm like, I don't think that's fair. And they're like, fine, I'll make it due by the end of the school day. Yeah, but you guys got a 4th period.
Yeah.
Yeah,
it's not even like we can do it like some of us. Like I work 3 to 10. I can't do it after school.
No, I literally, like, when we had half days, I would go to work, so like, at 11:40, I would drive to work at 12, be there from 12 to like 1.
Yeah, I literally have to leave here today. I have to go home, quickly get dressed, find something to eat if I have time, and then right to work, and then I'm there till 10 p.m.
I gotcha.
Or sometimes I have work, so like, I work till like, I think 5:30. I go home for like literally 10 minutes, and then I have practice like 5:30.
And I know, and I understand that.
It's a half day.
Oh, yeah.
But like I said, that's why I didn't make it due right away. So when you have the time to do it, and obviously, like if you turn it in at like 9 a.m., it's like, come on, am I really gonna care if it's 9 a.m.? So for those of you in the live stream, like I said, this is what we're going to be doing for the remainder of the class period. You're going to be working on one of these 2 assignments. You have until 12:23. Please make sure that you are getting this done in a timely fashion, as I will be needing to check these by Monday. But obviously, I have it due tomorrow morning.
Sorry, what's the big purple, the big like box for?
Technically, what they kind of hoped people to do was they wanted to be able to type in their work and answers, but I don't like that. I'm not a huge fan of like typing in the work and answers. Is that? Let me see. I don't think so.
It says view.
Yeah, I made it view only. I don't want you guys to, because I wasn't able to make a copy for you guys. You can make a copy if you want, but the way that it was set up for me, I had to copy it from someone else, and that's not us. And I wasn't allowed to, for some reason, it's very weird. I wasn't allowed to be like, make a copy for all the students. It's like, no, it's just view only, and then you guys can do what you need with it. You don't have to turn it into slideshow.
Okay.
You could write everything on a separate sheet of paper.
Okay.
Yes.
Maybe dance probably a little bit as well. Sorry. picture of the sheet, or do you want like the paper?
You can take a picture of the page that you're doing the work on. Yeah, but keep in mind, you may not be able to upload it with whatever signal you have.
Yeah.
So you could do that obviously later today. Yeah, we did it. Good job, crew. Woo! Please make sure you are getting those assessments or those enrichment or remediation done for me. Don't tell him his backpack's open. Oh, he walked out. All right. I didn't want his stuff to fall out.